Hello everyone, welcome back to Let's Unbound. Yes, we are in 1.6 polynomial functions and its end behavior. And as usual, be ready with pen and paper. So if you didn't get anything, pause the video, try to understand and move to next. And if you have any questions, comments, you can drop in comment section. We would love to help you out. Right? So here we go okay. So first, we are going to recall what is even polynomial functions and odd polynomial function. So even polynomial function, any polynomial is considered as even if it satisfies this condition, f of minus x equal to f of x for all x, for every x value, this should be satisfied. Okay, when this will happen, when all the powers of x are even, it's made up of only x power an even number. That kind of term alone will be there. And here on example, f of x is x power 4, then cube is missing. Okay, so no odd powers. The next square, the next term, because x power 1, right? So odd power is missing, and then 5. This is considered as even power term because 5 we can put x power 0. 0 is even, right? So this is all about even polynomial function, and graphically it has one significant feature. So that is here, you can observe it clearly. It's kind of quadratic, but not biquadratic also will look same. So if you increase it to 6, it will get little more flatter. If you increase it to 100, it will go flat like this. But anyways, the same structure. But the way it get flattered over that vertex point matters. Okay, coming to this. It is symmetric about y-axis. Any even function will be symmetric about y-axis. Yes, for polynomial function also, this condition will work, right? So now, odd polynomial function, let's see. A polynomial is odd if it satisfies this condition, f of minus x is minus f of x for all x. This happens only when your x is odd. Okay, no even powers of x. If your polynomial is made up of only odd power terms, then yeah, it's an odd polynomial function. X cubed plus 2x. And here we can see this is also a symmetrical function, but not about any line, about a point. It's symmetric about origin. This is your origin. It has origin symmetry. Any odd function will have origin symmetry. Of course, odd polynomial function also possesses that. Okay, what if I make, okay, if I make a polynomial purely made of cubes, like odd numbers, odd. If it's purely made up of even powers of terms, even. What if mix of both? For example, x square plus 2x plus 5. So this one is neither even nor odd. Okay, it won't be symmetric about y-axis. It won't be symmetric about origin. And also none of the two conditions will be satisfied. So combination will give you neither even nor odd. Okay, so that's the thing. Now, polynomial functions end behavior. So what is end behavior of any function means? This will describe how the graph behaves as x tends to infinity. You increase your x value, where your y value means the graph, where the graph is moving ahead or where it's growing up or down, something like that. When you're moving left, where your graph is moving. So that is, to describe this behavior, this is called end behavior. Okay. And it depends, for a polynomial function, it depends on two things, the degree of a polynomial and its leading coefficient, sign alone, not about numbers. So degree, and if you know leading coefficient sign, you can analyze the end behavior. So let's get deeper into this. Okay, what if we have even degree? And degree is basically even or odd, that's the thing. If you have even degree and positive coefficient, it both upward. Okay, as x tends to infinity, your graph will grow up. If your x tends to, yeah, this is minus infinity, I mean. So x tends to positive infinity, still it will go up. But even degree and negative leading coefficient will be the ulta version of it. So it will go down on both ends. So how should I write? As x tends to negative infinity, your graph is f of x or whatever its names tends to positive infinity because it's moving up and up, right? And then as x tends to positive infinity, your f of x still goes more up. This is the way we have to write. Okay, so even degree, both will look down. And yeah, you can mention is as x tends to negative infinity, f of x also going to negative infinity. As x tends to positive infinity, f of x also goes to negative infinity. Right? Now, so basically even degree means both the ends have same behavior, either positive infinity or negative. Positive infinity if it's positive coefficient, leading coefficient. That's simple to memorize. Now, Odd degree polynomial, how they behave. Odd degree and positive combination. Okay, so there will be a switch. Odd means one side is negative infinity, other side is positive. So here, if there is an arrow, as x tends to positive infinity, your graph is moving up. So positive infinity. So right side up, left side down. Up means plus infinity, this means minus infinity. So let me write as x tends to positive infinity, f of x tends to positive infinity. As x tends to negative infinity, f of x tends to negative infinity. Okay. Odd degree negative coefficient will have the ulta version of it. So x tends to negative infinity, f of x goes to positive infinity. X tends to positive infinity, f of x goes to negative infinity. So the ulta version of it. Right? That simple end behavior of a polynomial function. All you should understand is even polynomial, odd polynomial, how it behaves, end behavior based on degree. Degree means just even or odd, and coefficient just about the sign note of the leading coefficient. Okay, here we are moving to question 1. What is the end behavior of the polynomial? This polynomial. Okay, so right. It has even degree. Okay, so don't check the first term alone. They might give x power 7 here. Okay, so you should check it thoroughly, but here it's easy. Even degree and negative leading coefficient. Okay, what is it? Okay, even degree means either both up or both down. So positive both up, negative both down. So yeah, I have this combination. So it's both downward facing. But you can't write like this. You have to write as x tends to negative infinity, f of x tends to negative infinity. Down means negative infinity. Then as x tends to positive infinity, f of x tends to positive infinity. This is the end behavior. You have to write in this way. Right? And moving to, and also this is an even function. So we come across, right? Purely made up of even powers. So it is a valid even function, right? Okay, moving to question 2. A function f has the following end behavior. As x tends to minus infinity, f of x tends to minus. As x tends to positive, f of x tends to positive. Okay, so if it behaves like say minus infinity, plus infinity, plus infinity, we know this odd, in odd degree we come across like this. Odd degree and positive coefficient, or you can even quickly sketch this. Okay, positive leading coefficient. Okay, how can I make, okay, let's check. Minus infinity, the left side, it goes down, right side, it go up. Something like this. Okay, you have to connect. So odd degree and positive will do such thing. So give a polynomial function. You have to give a polynomial function. So give f of x, whatever they give, describe here. Odd degree, simply you can put x power a number. Like an odd number, 5, 15, 1, 5, 5, 2, 5, 7, 8, 9, anything. An odd number you can give. So let me make 5 plus x plus, no, I can't make any more like this. Okay, so just simple odd term like odd power x power an odd number, or combination of x power an odd number. Okay, and positive leading coefficient. So 1 is okay, or 10, 100, something you can use. Okay, and this can be negative also, no problem. Only leading coefficient have to be positive. So this is my polynomial function. If you got something interesting polynomial function, you can drop that in comment. And that shows his end behavior. Yes, this for sure, it will show this kind of end behavior to us. Right? Now, last question, very simple unit, subunit is this. Okay, a polynomial p of x has degree 7 and a positive leading coefficient. So odd and positive. If p of has 3 real zeros and 2 pairs of complex conjugate zeros, yes, 3 real, for example, x, y, okay, let me put a, b, c. Complex conjugates is, let me alpha means alpha bar, that is also 2 pairs, 1 pair and beta bar. So 7 zeros, 7 degree, yeah. And a positive leading coefficient, what is the end behavior of the function? Only thing here we have is, they give us classification of zeros. No, it won't affect your end behavior. Okay, end behavior purely depends on it, no matter how many zeros, how many non-real, how many real. So end behavior, let's odd and positive. So odd means one side. So one side is up, other side is down. So let's go. Positive means right side up, left side down. So we can write as x tends to positive infinity, f, okay, not f of x, p of x, right? P of x tends to positive infinity. As x tends to negative infinity, p of x tends to negative infinity. That's it. This is end behavior. Right, so that's it. And yes, I have a bonus question to you. Yeah, so coming to the bonus question. A polynomial function has an end behavior, following behavior. They have described it. You have to answer two questions. And what does this tell you about degree and leading coefficient? And write a possible polynomial function that shows its end behavior. Try for a very simplest form of a function. Okay, we can make many, but try to give the simplest ever possible polynomial function here. Okay, right. And you can drop these answers in comment. Also, your feedback is most welcome here. And last reminder, so if you would like to join our Let's Unbound student community WhatsApp group, here is a link. You can scan it and join to get updated with latest exam updates. And I will be meeting you next video very soon. Until then, keep learning, keep practicing. Stay tuned with Let's Unbound.